So Tom uses fencing to create a rectangular horse enclosure. He uses the side of the barn as one of the sides of the enclosure. Now this is like the down by the bay example, and we find that the maximum area, he has 48 meters of fencing, and which dimensions will use the entire 48 meters of fencing. So if he's got 24, actually I'll go through each one. So if the width is 8 and the length is 6, then the other width is going to be 8. So this will be 2 times the width plus the length. So the amount of fencing, so actually I'll put down F for amount of fencing, is equal to 2 times 8 plus 6, which is equal to 16 plus 6, which is equal to 22. Next one, and that only uses 22 meters of fencing, so that is not the right answer. We're going to use 12 here. So 2 times 12 plus 12 along this side. We don't need anything along the side of the barn, so that's going to be 2 times 12 is 24, plus 12 is 36, so that's not right. And for the width of 24, it's going to be 2 times 24 plus 12. Well, that's 48 plus 12. We can automatically eliminate this one because that's not possible, because it will use the entire amount of fencing, but we don't have enough fencing to do that, so that's not correct. For the last one, F is equal to 2 times 12 plus 24, and 2 times 12 is 24. 24 plus 24 is 48. So the answer is D. Consider the following triangle. Which expression can be used in the process of determining the length of the base? Well, remember this is c squared equals a squared plus b squared, which is Pythagorean theorem. And we're going to use then subtract a squared from both sides. So b squared is equal to c squared minus a squared. We subtract a squared from both sides. Now b squared is going to be the length of this leg, where we're saying it's the base. And so now we sub in. So b squared is equal to, and the hypotenuse here is 16. So 16 squared minus 3.5 squared. And we have to take the square root of both sides to find the length of the base. All right, and so the answer then is going to be A, because that is the one where it's used in the process. We don't take the square root of we don't simplify first. We have to take the square root of everything. So the answer, be careful, is not D. Okay, Pablo is designing a rectangular flag that consists of 3 colored triangles. The picture below shows the colors of the triangles and the cost of each color of material. What is the total cost of the material? What you have to do is figure out the area of each triangle, and so this is going to be 50 by 50, and the area is 1/2 base times height, and so to be 1/2 of 50 times 50, which is equal to 2,500 times 1/2, which is 1,250 centimeters squared. All right, so that's for the area of the green. And you're going to have to continue on doing the same thing here, the area of the blue. So this is for the green. area of the blue is 1/2 times 100. Sorry, 100. That's not, times 50, which is equal to 1/2 times 50. 1/2 times 100 is 50. 50 times 50 is 2,500 centimeters squared. And the area of the red will be the same as the area of the green. So that will be 1,250. The cost will be equal to the cost of the green section, which will be 1,250 times 0.02. So that's the area of the green, plus the area of the red, which will be 1,250 times the cost per square centimeter, which is 0.03, plus 2,500 times, and this was 0.01. Okay. And so when we do this calculation, $1,250 times 0.02 plus, so $25 for the green area, and 1,250 times 0.03, and it was $37.50 for the red area, plus 2,500 times 0.01 is going to be 25 when you do it on your calculator, so plus 25. And you come up with $87.50. So the total cost then is $87.50. So our answer is B. A cylinder has a volume of 400 pi centimeters cubed and a diameter of 10 centimeters. Which of the following is the closest to the height of the cylinder? Well, if volume is equal to pi r squared times the height, and if we want to solve for the height, then we're going to divide both sides by pi r squared. So H is equal to volume over pi r squared, which is equal to, we're told the volume is 400 pi. And the diameter is 10. So if the diameter is 10, the diameter is 20, the radius is 10. So we're going to put in, and I switch this around because this is going to be 10 squared times pi, which is equal to 400 pi over 100 pi. The pi's cancel out. 400 divided by 100 will be 4. So our radius, the height of the cylinder is 4 centimeters.